Hi students, in this week's video, we're moving on to integrations of trigonometric functions. Do get ready a pen and some papers and practice along with me. We have learned how to find the derivative of sine x to be cos x, the derivative of cos x to be negative sine x, derivative of tangent x to be secant square x. So since integration is the opposite of differentiation, when we integrate cos x, we're expected to get sine x plus c. When we integrate sine x, we're expected to get negative cos x plus c. When we integrate secant square x, we're expected to get tangent x plus c, where c is an arbitrary constant. And we can extend this knowledge to integrations of sine bracket ax plus b to give us negative cosine bracket as plus b over the differentiation of whatever is inside the bracket, which is ax plus b, and that will give us a. So we end up getting negative 1 over a cos bracket ax plus b and plus c, which is arbitrary constant. Similarly, when we integrate cos bracket ax plus b, we're expected to get sine bracket ax plus b over a, which can be written as 1 over a sine bracket ax plus b and plus constant c. Likewise, when we integrate secant squared bracket ax plus b, we're expected to get tangent bracket ax plus b over a, which can be written as 1 over a tangent bracket ax plus b plus c, which c is the constant, where c is the arbitrary constant. So this is the concept needed for the next few slides. Right, let's look at question 1. So for question 1a, we're asked to integrate 2 minus sine x dx. So we're going to integrate 2 and also integrate sine x separately. So integrate 2, you get 2x. You think of it this way, if you differentiate 2x, you get 2. So integrate 2, you get 2x. Integrate sine x, you get negative cos x. So you put them together, you would get 2x plus cos x plus c. Okay, we can just pull 3 out from the integral sign. So you get 3 tangent x plus 5x plus c. And for cos 4x, okay, integrate cos 4x, you get sine 4x, but not to forget, you need to divide by the differentiation of 4x. So you can just bracket 4x, just to remind you that you need to do one more step, that is divide by 4. So you can write it as 1/4 sine 4x plus c. Okay, let's look at 1d. So for 1d, we're just going to pull your negative 2 out from the integral sign. And then integrate sine 3x, you're just going to get negative cos 3x. And then not to forget, you need to divide by the differentiation of 3x, which gives you 3. And simplifying it, you get 2/3 cos 3x plus c. Let's move on to part E. Pull out negative half. Integrate sine x over 2 will gives you negative cos x over 2. Divide by half. Okay, because when you differentiate x over 2, you can actually write it as half x. X over 2 has the same meaning as half x. X over 2 is just half times x over 1, which actually just give you half x. So you differentiate half x, you get half. Alright, so here what we can do is you can just use that simple trick, multiply by 2 at the numerator and 2 at the denominator. And you end up getting, okay, and the negative will gives you a positive. So you end up getting cos x over 2 plus c. Let's look at f. Right, so we're going to pull 3 out from the integral sign. And we're going to integrate secant squared 3x over 2 that give us tangent 3x over 2 divide by 3 over 2. And you're just going to pull the simple trick again. So that will give you alright. Alright, let's look at 4a. Right, so integrations of secant square x minus 4 sine x, integrate secant square x, you get tangent x. Integrate sine x, you get negative cos x. And you end up getting tangent x plus 4 cos x plus c, where c is arbitrary constant. Let's move on to 4b. You will get 3 sine x plus 2 cos x plus c. Let's move on to part c. You will get 4 sine x plus 3 tangent x. Alright, so what we have done so far is just direct applications of the direct applications of how we integrate trigo functions. Right, let's look at question 5. If you look at question 5, this is the kind of very popular this is a very popular type of questions that you may see in the exam, right? Because differentiation integrations, they are very closely related to each other. So for part I, you are asked to differentiate, and then part 2, make use of the answer you have found in part I to solve whatever you asked to solve in part 2. So if you see the word hence, means you have to make use of part I's answer. So that's differentiate sine bracket x squared plus 2x. So differentiate sine, you get cos bracket x squared plus 2x, then times the differentiation of x squared plus 2x. So that will give you, and you can just factorize the 2 out. So that will give you 2 bracket x plus 1 times cos bracket x squared plus 2x. So this is the answer that we'll be using to do part 2. So for part 2, this is what you write down, because this is what you have got for part I. So you start with what you have found for part I. And then we're going to add the integral sign to both sides, and then multiply with the x. Add integral sign plus multiply with the x. Okay, and then divide. Put whatever you need to find on the left side and whatever on the right. That means the left on the right and right on the left. And this is cancelled off because it's opposite of each other. So you're left only with sine bracket x squared plus 2x. If you look at what the questions require you to find, you need to get rid of the 2. Alright, so to get rid of the 2 means you divide by 2. So you can see divide by 2 as times half. Okay, so this is how you solve question 5. It's a very popular kind of exam questions. So it's good that you acquire this skill to solve this kind of question. Right, it is important that we revisit some of the trigo formulas we have learned, because these 3 topics are actually very much interrelated. Trigo, differentiation, integrations. And when you go on to integrations of the logarithmic functions, you realize that you need the concepts of partial fractions. Right, so therefore it is important, all right, that we need to revisit some of these concepts. Right, so besides the trigo identity, of course, there's another 2 more trigo identity. 1 plus tangent square x equals to secant square x. 1 plus cotangent square x equals to cosecant square x. We must also take note of your double angle. Sine 2x equals to 2 sine x cos x. Cos 2x is 1 minus 2 sine square x, so on and so forth. I'm listing only some of it because this is what we'll be using later on. So it is good to memorize all this formula, put it at the back of your head, so anytime you need it, just pull it up. Okay, so we're supposed to show that the expansions of sine x minus cos x squared will give you x. The integrations of the expansions of square root of sine x minus cos x will give you x minus sine square x plus c. So we're just going to expand this using our algebraic identity. Alright, and we're going to group sine square x with cos square x. And sine square x plus cos square x will give us 1. And 2 sine x cos x will give us sine 2x. So we are actually integrating 1 minus sine 2x. So integrate 1, you get x, and integrate sine 2x, you get negative cos x divided by 2. Okay. And we're not done yet, because if you look at the answer is actually expressed in terms of sine square x. So this is where I need to apply this formula to replace my cos 2x with 1 minus 2 sine square x. Alright, and because I'm actually integrating an indefinite integral, I need to add plus c1, and I have a constant half and another constant c1, so I'm just going to group these two constants as c, where c is just an arbitrary constant. Right, supposing you asked to integrate cos square x dx. If you were to recall what we have, the previous homework that we've done, in one of the questions, we are asked to show that integrations of fx multiplied with g of x dx, this is not equals to integrations of f of x dx times integrations of g of x dx. Also, if you integrate f of x divided by g of x dx, this one is not equals to integrations of f of x dx over integrations of g of x dx. So we have actually, in the previous video, we have actually shown these two formulas that does not work. So therefore, therefore we can't say that this is equals to integrations of cos x dx times integrations of cos x dx. Okay, this is not correct. So if that's the case, then how do we go about integrating cos square x? So that is what I mean by saying we need to revisit the three Go formulas. Okay, and one of it is our double angle. Our cos 2x can be written as 2 cos square x minus 1, right? So 2 cos square x will just give me cos 2x plus 1. So therefore, cos square x is actually the same as half cos 2x plus half. So with this, I can actually rewrite my cos square x as half cos 2x plus half dx. And with that, I can just integrate it. So that will give us half, integrate cos 2x will get sine 2x divided by 2. Integrate half will get half x. So you simplify further, you have 1/4 sine 2x plus half x plus c, where c is arbitrary constant.